Hi, good morning. Where did we stop yesterday? Did we get through all of part A?
No.
No, we didn't.
Right there.
Okay, good. All right, so I didn't know this is the worksheet. So, you ever have this worksheet from yesterday? Okay, so I talked about how we want to make substitutions with the numerator, get it out of function notation. So we know f of x is easy to replace. That's going to just be the original expression, but we have to make sure we are building our f of x plus h correctly. So first thing we do is we rewrite the expression with parentheses in place of x, and that way we have a space set aside exactly for where x plus h is supposed to go, and then you'll never make a mistake putting x plus h in the wrong spot. So they will go directly inside the parentheses, and once we do that, then we are just making our substitutions. In for the numerator, f of x plus h gets replaced with 3 parentheses x plus h plus 7. We talked about how we got to be careful with f of x because there's a minus in front, and that negative is not just going to impact the first term, it's going to impact every term that comes after it. So we put a parentheses around f of x as a visual reminder that the negative will impact every term in f of x. So from here, we can clean up, distribute, combine like terms, and see how far we can get to our cleanup stage. Okay. So I'll distribute the 3 through. Bunch of things cancel out. We're just left with 3h over h, which can go even further to just be 3. Questions with 6a? I want you guys to try part B. So same idea. This is now the function for us replacing into that expression above. Build your parentheses so that you can be able to put that argument of x plus h in the right slots. Basically, everywhere you see an x, leave an open space where that x was, and that way you can insert the x plus h in their corresponding locations. From there, get it to this form. Replace the first term with f of x plus h. Replace the second term with f of x all over h. But I would say for part B, just stop at this point. I think the cleanup stage is a little bit more, well, it's just because I didn't provide enough room. So if you guys can just get to replacing the numerator out of function notation. That's what I want to see for now. Okay, so try that. So this. Yeah, I'm seeing a slight mistake here that as you are making your parentheses, make sure that you don't lose the exponent too, right? So that exponent 2 is still going to be part of your expression. You're just going to replace the x with a set of parentheses. So I'll make sure that we are slotting it in the right spots here. So once I replace all my x's with parentheses, then I'm going to start inserting x plus h into my expression. So now I'm going to take what I found and put it into that form. Okay? So I'm starting with f of x plus h. That's what we just found. So that's going to be the first thing we put in the numerator. Minus parentheses, f of x goes next. That's just going to be my original expression, all over h. Questions there? Okay, so technically we could clean this up further, expand everything out, but right now I'll just have you guys leave it in that form. I do want to point something out, though, is as this came to my attention from the previous period, is how would you expand this 3 parentheses x plus h squared?
3 parentheses x squared plus 2xh plus h squared.
Good. So order of operations. Okay, we can't distribute the 3 first and then square. The exponent is going to take precedence, so we have to basically do this part first. Once we FOIL this out, then the 3 can take its turn and distribute through. Okay, it feels like it's, I know that sometimes we want to do that 3 first because we want to read from left to right, but we got to keep in mind exponent has to be takes priority, and then once we can get everything resolved with the exponent, then we can distribute 3 through. And again, we can't just say that x squared plus h squared, right? We got to spend the time to FOIL the binomial out. So yeah, a couple of things I want to point out. It seems couple mistakes that can occur from that term. Okay, so that's part B. Any questions there? Okay, so part C. See if you can try part C. So same idea. Rewrite your problem with a set of parentheses wherever the x was. build your expression, and then I'll help you with the rest, okay? Because the rest requires a common denominator, dealing with complex fractions, and I do want to spend the time to walk you through those steps. But can you just get the numerator out of function notation first? Get into this form, then x plus h. Okay, so here's our starting points. Put parentheses where the x was. And now you have a perfect place to enter your new argument. Okay, so we're going to start with the f of x plus h first, then subtract the original function all over h. Okay, so from here, are we okay up to this point? Okay, so let me walk you through the rest of the stage here. We're going to try to do a little bit of cleanup. Okay, so a couple of things need to happen. We need to get this to clean up to be one fraction, and then we also need to resolve this complex fraction. So there's two things going on here. We got to find a common denominator, and then we don't want this fraction within a fraction. We want to resolve this issue. So we're going to work this in separate stages, or two stages. We're going to focus our attention here. This is something that we can work with. So we're just going to focus on common denominator. So we're going to clean up this expression first. Okay, so I'm just going to work on this here, and then once I'm done with this, I'll put this back where it belongs, and then we can work in that h and figure out how to clean that rest of it up. But right now, I'm just going to find a common denominator, get this down to one fraction. Okay. So I'm just going to focus on that portion there. So common denominator. Okay, what's my common denominator between these two fractions? Good. So we need something that will allow both these factors to multiply into. So something inclusive of both of these denominators. So that's going to have to be x and x plus h. Next thing is we need to balance the fractions. We have to compare between each of the old denominator with the new denominator and figure out what's missing so that we can multiply the numerator by the appropriate factor. So what's missing between this old denominator and this new denominator? X. So that's going to tell us exactly what I need to balance out with my numerator. I need to multiply the numerator by an x. Okay. What's different between my old denominator and my new denominator here? X plus h. So balance the numerator with x plus h. Okay, so we're making progress because now we have common denominators. Once we have common denominators, we can merge them together, and now it's fair game for us to combine like terms with the numerator. Right? We couldn't do it before with the denominator not being the same, but now that we have everything balanced, we can combine everything we see in the numerator and put it all under one fraction. Okay, so I'm going to merge all this together. I'm going to also take the time to distribute the -6 through the x plus h. I'll just take care of two things at once, distribute this through. So -6 times x is -6x. -6 times h is -6h. Notice that I'm still focusing on this stage of my expression. I can do a little bit of cleanup here. The 6x's cancels out. So that leaves me with -6h. So now I'm going to bring this back to my larger problem and put it all over h. Right. So I know it doesn't look like it's a lot simpler, but we did achieve a common denominator. We did achieve, so that makes it easier for us to work with that h when we want to cancel things out. Okay. Everybody good up to this point? Okay, so the numerator is as cleaned up as we can get. Notice that we can't cancel these h's out, right? You can't cancel across addition or subtraction. So these are kind of, this is as far as we can go. But now we want to resolve this complex fraction. We want to find a way to maybe merge this h with the rest of the numerator term. So I want to bring this h up to the same space as this numerator. So I'll multiply by the reciprocal. The h's cancels out here. And now we have everything under one, or easier for us to see what we can do. What can we do to clean this expression up? Good. The numerator denominator matches. There's no addition, subtraction getting in the way. Numerator denominator h will just cancel out nicely for us. Okay, any questions there? So we reviewed common denominators. We reviewed working with complex fractions. We're going to see these types of problems show up in the next 2 units. So I want to make sure we can be familiar with these algebra steps. Okay, questions? All right, 24. We want to find horizontal asymptotes, vertical asymptotes, holes, and also x-intercepts, if you can include that as well. So as I go through part A, I'm also going to go through notes. I'll give you guys notes on, or help remind you how to find horizontal asymptotes, vertical asymptotes, holes. So it may take more space than this. I'm going to put this on a separate sheet, but it's up to you whether you want to take down these notes, okay? So I'll put this here. So I'm going to start by factoring everything out. If we factor everything out, we can see all the individual pieces a little bit easier, and we'll be able to kind of identify where the asymptotes are, where the holes are, where the x-intercepts are. So I'm going to start off by factoring. So numerator here, both sides to be -8, asymptotes to be -7. If you want to go through star method or whichever method you use to factor. All right, so here's my factored form. Okay, so if you look at your factored form, you see some common factors, right? So let's cross those out because this will be an indication as to one of the traits of this graph here. So whatever cancels out between numerator and denominator, that's going to be how you find the location of your hole. So from that 2x plus 1, we're going to find the holes from your canceled terms. Or canceled factors. Anything that is left in the numerator, that's going to be how you can identify the location of your x-intercept. You see how the x minus 4 still remains, it doesn't go away, it's in the numerator. That's going to be, so factors in the numerator will be x-intercepts. Or remaining factors in the numerator is how we find x-intercepts. Okay. Remaining factors in the denominator is how we can identify the location of our vertical asymptotes. Okay, so I'm kind of giving you notes as we are working through this example. And I also want to give you some notes about how to find horizontal asymptotes. Okay, so I'll put this off to the side. So the strategy to find horizontal asymptotes, right? These are going to be these hidden lines where the graph is going to kind of flatten out as it exits the graph, right? Where's that graph? Where's that line, that imaginary line where the graph is kind of that ceiling or that floor that the graph will never to reach the other side of? Is we do by comparing degrees between numerator and denominator. So let me give you some scenarios here. First scenario is if the numerator and denominator have the same degree. Okay, so here's an example. Okay, so I'm going to identify the highest exponent, 3 up top, 3 below. Notice the degrees match. So I'm just going to look at the number that is attached to those variables, and that fractional value is my horizontal asymptote. Okay. Second scenario is where my denominator has the higher exponent. So I'm going to circle the exponents so we can compare them. Notice how the denominator is greater. If the denominator is greater, we don't care about what the ratio is, but there will be a horizontal asymptote, and it's always going to be at 0. And then finally is if the numerator wins out. If the numerator has the higher degree, then we don't have a horizontal asymptote. Okay, so we're going to apply these steps to help us find the horizontal asymptote for our particular problem. Anybody still need this? All right, so let's go back to our problem and see with all the notes whether we can find all the parts, pieces that we're looking for. Okay, I'm going to start here. X-intercept is coming from that x minus 4. So I'll set that expression equal to 0, solve for x. There's my x-intercept. I'm going to just indicate the order pair. Okay. Next up, I'm going to move to my remaining factor here. This is how I'm going to locate my vertical asymptote. Solve for x. X equals -2/3. That is where the vertical asymptote will will live. Okay, next up, I see cancel terms. I know that will be the location where a hole in the graph will exist. So set one of your canceled factors equal to 0, solve for x. But something that's different between holes and vertical asymptotes, these are both locations where the graph don't exist, but vertical asymptote is a line that the graph is never going to cross over. But a hole is an ordered pair that the graph is not going to exist. So if I want to find a hole of the graph, I also need to find the y value because I want to find the physical location on the graph. So the way we do that is we have to take the -1/2 and insert it into the reduced expression of our original function. Okay. So the hole is going to be, there's going to be a x value of -1/2, but we need to find the y value. So I'm going to take my original problem, I'm going to remove the hole, I'm going to rewrite that reduced expression, I'm going to insert -1/2 where the x's are. Okay. I'm going to insert the -1/2 in for the x's. It's a little messy without a calculator, but I'll give you the value. So all that is going to clean up to be -9. Okay, so that's how you find your hole. You take your canceled out factor, you set it equal to 0, you solve for x, but then once you solve for x, remember you still got to find that y value. So you go back to the original expression, remove the hole, get that reduced expression, and then re-evaluate that x value that you just found, and that will give you the location of that hole. Okay, questions? Now, with horizontal asymptotes, everything up to this point, we've been using the factored form to help us find x-intercepts, vertical asymptotes, holes. But to find the horizontal asymptote, I think it's easiest if you go back to the original problem. If you go back to the original problem, it's a lot easier to identify the highest exponents, a lot easier to find your leading coefficients. So we don't want to use the factored form for horizontal asymptotes. We want to use the original problem. So I'm going to go back to the original problem here. Okay. I'm going to locate the highest exponent that I can find. They match. Therefore, my horizontal asymptote is what? Not just 1/3. We're going to say what? Y, yeah, y equals, right? You want to write the equation of that line, y equals 1/3. Because if the degrees match, we're just going to be looking at the ratio of the coefficients, and we're going to have to make sure it's a horizontal line, so we want to give it that equation that y equals. Okay, do all the steps make sense? Yes. Okay. So horizontal asymptote, we go back to the original equation, and we identify the highest exponent. So my highest exponent is 2 and 2, and we see that between those two, they are the same. Okay, so if I have matching degrees, then there is a horizontal asymptote, and the horizontal asymptote is just going to be the ratio of the coefficients attached to those variables. So 2/6 is reduced to 1/3. Good. Any other questions? So with these notes here and this example and part A that we did, can you try part B and follow the steps that we highlighted, just so that you can get that practice in, and also for me to see, does everything make sense? Okay, so try 24B. Again, when you're dealing with a hole, after you find your hole, in this case, the hint is that there's going to be more than one hole. Once you find your hole, plug that x value back into the reduced expression. So remove all the holes, you'll get a simplified expression, and then just insert that x value into that simplified expression, and that will give you the y value where the hole lives. Right, but first things first, start by factoring, right? You got to get your factors showing so that you can receive individual pieces. Okay, so we're going to term this. The greatest common factor more than one. X, 5x. So basically, if I divide everything by 5x, what's left? Here, factor, take out the GCF first, and then you can do trinomial factor. So, yeah, take out x first. And what's left? Got that right? Yeah. So now I go through factoring, right? Whatever method you use, guess and check, grouping, star method. Or how do you do factoring?
Well, that's how I did it, but I don't remember that.
Multiplies to be negative 28, adds up to be negative 3.
What? Okay.
So hence, you're going to have two holes in their graph. here, you're not going to go through. You're not going to go through. But see, so you do that context. That's right. So x, okay, you can see how there's a common x. I didn't get that. Now you can take that. Yeah, this is complete. Yeah. Get to this point where you match and see where you're at. What do you think about that? So you see how the previous problem had an x left over, so that's why there wasn't x-intercept. For this one, you see how all the x's are gone in there. So there's none.
Oh, okay.
So all the x's are gone.
Actually, there's nothing to them. See that x there? That x is also here. You gotta break that down as well. So that constitutes as a cancel term. The 5 just stays. The 5 stays. You can think of the 5 as outside of x. If you want to put it here, it's easier on the x. The 5 just kind of live there by itself. Right. Once you factor everything out and cancel all the matching terms, matching factors, you're going to see that there's no more x's left in the numerator. There's still a 5 there, but that 5 is not enough to produce an x-intercept. So you should be getting none for your x-intercept. Whenever the denominator is higher, you get the denominator is higher, it's always 0. So make sure you say 1. Oh. That's right, no x-intercept, because all the x's are gone. The 5 is not going to do anything to produce it. Is that me? Here's that x. That x is
Oh,
all right, let me show the answer. I'm sorry? That's right. 0, but you got to plug 0 back into your reduced expression. Yes. Plug both holes into the 5 over x minus 7.
It's not like really everyone else trying to escape ABC now. I'm like, should have done AB.
Okay.
writing here.
Are we good with finding holes? You should be getting two holes, 0 and -4. And the way we find the y value is produce your reduced expression. So the reduced expression is just remove all the holes and see what's left over. So now I can plug 0 in here. That'll give me my y value of the hole. Plug -4 into my reduced expression. That'll give me the y value of my hole. No x-intercept, vertical asymptote at x equals 7. The reason why the horizontal asymptote is y equals 0 is because if I'm looking at my original equation, my denominator has the higher degree. If my denominator has higher degree, it's always going to be y equals 0. We don't care about the coefficients or the ratio. It's always going to be 0. Okay, any questions? Okay, so Monday, first thing I'm going to do is I'm going to be checking your homework. So your homework assigned in your calendar from P1, P2, and P3. Make sure you show your work. I have solutions on my website. You should be able to find it under Tuesday. I will send you a reminder on Sunday afternoon, so that if you forget, hopefully that will remind you to finish out your homework. Okay. I'm just going to do a spot check. So as I'll walk around the beginning, have your homework out. I'm just going to see that you're showing your work, and you'll get credit for 3 homework assignments. Okay. Oh, okay. Yeah, and okay, you can email me. I'll be sure to
So the hardest one is I'm like,
here's back it. Silence for my remind.
Okay.
oh yeah, it's not
First, I'll try to get it to you. But
Yeah, I'll set up. And is this all the forgiveness, so I just?
This will come from.
Oh,
that's.
All right, well, I saw that.
Yeah.
I see the graphics.
I know.
I never talked, I'm taking like AP physics maybe and all that stuff, so it was,
So.
Oh, really? Well, just like.
I
got AP bio.
What?
I got AP bio.
I've heard AP bio is easier than both of those.
Yeah, no, I didn't. The bio's just harder for me.
Yeah, I mean, it depends on.
Yeah.
It was not hard, I swear.
Okay. Perfect. All right.
It's extra hot.
Hey, don't forget.
Screw them.
Great.
It gets over, I hate it.